where I go through at least one of each of these delta math problems, just so you can see the process. And I will kind of narrate my steps. Hopefully that's helpful. I'm just gonna start with the first one. These problems are the notes that we took yesterday, also on Friday, right? So we are finding the derivative, dy over dx, for these weird sorts of functions that have x and y all mixed up, right? So it's a lot messier. Okay, what were our steps for that? Well, step one is we're going to take d of dx, so the derivative with respect to x of both sides. So this first step is very straightforward. I'm just going to show, I'm going to take d over dx and literally do d over dx for both sides. So I take d over dx, and in these brackets, I'm just going to plug in my equation that I see. So I see x plus x squared, so I'm going to write x plus x squared. And then on the right, I have negative 4y cubed plus y squared. Cool, that's step number one. That's it. I didn't adjust anything else. All I did was take d over dx of both sides. All right, step two is going to be take the derivative of each term. I'll say regularly, but for every y term, multiply by dy over dx. All right, so this one is like the key step for implicit differentiation. So we're going to take the derivative of each term regularly, but this is the key step. For every y term, I multiply by dy over dx. Cool. So let's do that. I take the derivative starting with x. The derivative of x is 1, right? It is not a y term. It is not a y term, so I'm good. I do not need to do anything else. Derivative of 2x squared is 2x. Cool. Write an equal sign. Let's continue going. Derivative of negative 4y cubed, this term right here, that is going to be negative 12y squared. And I'm going to ask, is this a y term? Yes, this is a y term. So if it's a y term, I also have to multiply this by dy over dx. Cool. Plus, let's take the derivative of the next term, y squared. First, I do the derivative regularly, so it's going to be 2y. Then I also multiply by dy over dx. Cool. That is step two. Step three, if I just want to make it simple, I'm just going to solve for dy over dx. dy over dx is my derivative, so I just need to solve for that. Well, how would I go about doing that? Well, first thing, notice I have all my dy over dx terms already on the right side here, so I can just factor out dy over dx. So I'm going to do that. I'm going to rewrite this out of the equation. Nothing changes here. So 1 plus 2x is equal to, here though, this side, I'm going to factor dy over dx out from both terms. So I'm going to take dy over dx out. So dy over dx, I take it out. I take it out of negative 12y squared, so negative 12y squared plus 2y. Right, so I took it out of both these terms. If I were to, this is like sort of like foiling. If I were to multiply this back in or distribute this, it'd be dy over dx times negative 12y squared plus dy over dx times 2y, right? But I factored it out. Cool. To get dy over dx by itself now, I just have to divide both sides by this. So I'm going to divide 1 plus 2x, just 1 plus 2x. I'm going to divide it by this. When I divide it, the whole equation by this, just this, I'm left with dy over dx by itself. So dy over dx is going to be just that. So let's write that. 1 plus 2x divided by negative 12y squared plus 2y. Submit my answer. Boom. Cool. All right. I'm going to move on now to the harder problems, right? These are the tougher ones because, so I did implicit differentiation level 1. Let's do a level 2 problem now. All right, I'm going to keep the steps written because the steps are the same. The steps are the same. It just, you'll see why it levels up, sort of. All right. Okay, let's start with step one, take d over dx of both sides. Easy. I'm going to do the exact same thing. I just take d over dx and I just plug this equation in. I do that for both sides. So negative xy plus 3y squared. I didn't change anything about this. It stays the exact same. Then on the right side, it's derivative of negative x. Good. Okay. Here's where it gets challenging, step two. So step one is super easy no matter what the problem is. Step two is going to take a lot more work. Okay, take the derivative of each term regularly, but for every y term, multiply by dy over dx. All right, let's take the derivative of each term regularly. So when I look at this, negative xy, how can I actually take the derivative of this? Well, hint, it's going to be kind of hard. To actually take the derivative of this, I need to do a product rule. So I'm going to write for this first term, I actually need to do a product rule. I'm going to write that as negative x. Here, I'll write v is equal to y. What else do I need to write? I need to write u prime. U prime is the derivative of negative x. That's just going to be negative 1. And v prime is the derivative of y, and that's just 1. However, remember, every y term, when I take the derivative, I need to multiply by dy over dx. So I actually multiply this 1 times dy over dx. So actually 1 times dy over dx is just dy over dx, right? So u, v, u prime, and v prime. Right? And I needed to do product rule for this first term because I actually almost can't take the derivative of it regularly. For me to do it regularly, I need to do a product rule for this, right? I need to do a product rule because it's negative x times y. There's two separate functions there. All right, so let's just plug this into my product rule formula then. My product rule formula is uv prime plus vu prime. Whoops, vu prime. All right, so I plug it in. uv prime, that's going to be negative x times dy over dx plus vu prime. Vu prime would be y times negative 1. So I guess I can write that all out. Y times negative 1. Cool. So after I do my product rule, I realize, that the derivative of this first term, after I do my product rule, the derivative of that whole first term is that thing, what I just did product rule for, that whole thing. I know it's sort of annoying, but that is my product rule. So I'm going to put this first thing in brackets just so I make it very obvious, because this is where the majority of our work is. I had to do product rule for this, right, for this thing. Cool. Now let's continue. Derivative, I did this term, right? I did that negative xy. Let's go to 3y squared now. Derivative of 3y squared is plus 6y. Cool. And then it's a y term, so I have to multiply by dy over dx. All right, that's equal to the derivative then of the other side. The derivative of negative x is just negative 1. All right, cool. So, I mean, that's it. Let me copy and paste this. And we're going to move on to step 3, which is just solve for dy over dx. So let's simplify this. All right, just to make this simpler, I'm going to write negative x dy over dx plus y times negative 1, that's just minus y, plus 6y dy over dx is equal to negative 1. Cool. So I simplified it a little bit. Now I want all the dy over dx terms on one side of the equation. So I have 6y times dy over dx. That's one term because they're multiplied together. Negative x times dy over dx is one term because they're multiplied together. The only term that's by itself is this minus y here. So I'm going to add y to both sides to get rid of it, right? So this side, I'm going to add y. When I add y, I get rid of this minus y. And then on the right side of the equation, I would also have to add y. All right, now what I can do is factor dy over dx out from this. So I would factor dy over dx, factor it out. And when I factor it out, I'd be multiplying dy over dx by negative x plus 6y. That's equal to this right side of the equation stays the exact same. I didn't factor anything out. Now to get dy over dx by itself, I just need to divide by this, both sides of the equation, divide it by this to get it by itself. So it's going to be dy over dx is equal to negative 1 plus y divided by negative x plus 6y. All right. Negative 1 plus y, negative x plus 6y. Cool. All right. Let's continue. That's level 2. I'm not even sure what level. Okay. All right. Let's take a look at level 3. Same steps. Remember, same steps. Just same steps. We just have to apply our derivative rules. Okay. Now, we had time to go over I believe a quotient rule example in class, and a product rule example was on the exit ticket. This one, though, looks like it's neither of those. So we'll take a look. But this is why it's important to know our derivative rules. So step 1, easy. I just take dy over dx of both sides. Nothing changes. So I'm going to write x plus 3y, or square root x plus 3y. Cool. That's equal to 4y. Okay, one thing I'm going to do in this first step, though, I already know these square roots. I don't really like dealing with them, right? Square roots can be confusing. I'm going to rewrite this just right off the bat as a fractional exponent. So instead of x square root of x plus 3y, it's going to be x plus 3y. And I'm going to put this to the 1/2 power, right? Just right off the bat. And hopefully we remember that that is a rule. Okay, we're going to take the derivative of each of these terms regularly, step 2, but for each y term, multiply by dy over dx. Okay, so I take the derivative. My first term, though, is this whole thing. It's this x plus 3y. It's all in parentheses to the 1/2 power. How do I take the derivative of this? It looks like it's a function within a function, right? And it is. So I actually have to do a chain rule, right? Chain rule is if I have a function within a function, in this case, g of x is inside of f of x, what do? Well, I take the derivative of the outside function, I leave the inside the same, then I multiply by the derivative of the inside function. Okay, so just for this first term here, which is kind of a long term because it's all in this 1/2 power thing, all in these parentheses, I need to do chain rule. So first, let's take the derivative of the outside. Well, the derivative of the outside function is this 1/2, right? So my outside function is the 1/2. So I'll actually label this outside is this 1/2. My inside function is this x plus 3y. X plus 3y. Okay. Derivative of the outside, right? So I'm following my chain rule. Derivative of the outside. Derivative of the outside would be 1/2. Then I use my power rule, so 1/2 minus 1 is negative 1/2, right? I took the derivative of this, which according to my power rule, I would bring the 1/2 out front, and then I subtract 1, so it's negative 1/2 on the outside. Remember, I leave my inside the exact same, so the g of x stays the exact same. That means x plus 3y, this inside part, stays the exact same. Cool. Notice I only took the derivative of my outside, this 1/2, so I didn't take the derivative of any y terms yet. So I don't need to multiply by dy over dx, none of that, right? I just, and following chain rule, took the derivative of this 1/2 thing. Okay, let's continue though. I need to then multiply by the derivative of the inside. So I'm going to multiply this whole thing by the derivative of the inside. Now, what is the derivative of the inside? Well, derivative of x is 1. Derivative of 3y is 3. However, I did finally take the derivative of a y term, so I need to multiply by dy over dx. So 1 plus 3 times dy over dx. Okay, so that is the derivative of this whole term. I followed my chain rule because there's an outside function and an inside function. Okay, hopefully that is definitely going to be a little confusing, but hopefully it wasn't terrible to keep up with. Let's continue. So I did this whole left side. Let's go on to this right side. Derivative of 4y is 4, and I did take the derivative of a y term, so I'm going to multiply by dy over dx. Excellent. Cool. Now, what do we got to do? We have to solve for dy dx. So let's solve for that. So this is sort of confusing because it's this whole thing times 1 plus 3 dy over dx, right? 3 dy over dx is equal to 4 dy over dx. Now, I want to get this 3 dy over dx by itself. However, it's contained within this term where it's added plus 1 and being multiplied by this. So it's actually quite attached to everything else. So I'm actually going to distribute this first, like multiply this out before I can move this dy over dx term to the other side. So I'm going to multiply 1/2 x plus 3y to the negative 1/2. I'm going to multiply this by 1. So I'm just distributing this. This times 1 is the same exact thing, so I don't change anything. Then this times 3 dy over dx. So it's plus, so this times 1 plus this times 3 dy over dx. So this times 3 dy over dx would be 3 over 2 x plus 3y to the negative 1/2 dy over dx. Cool. And that's equal to 4 dy over, 4 dy over dx. Well, so I just distributed this, distributed. All right. Now I actually have a clear dy over dx term, so I'm going to move this to the other side by subtracting it. So I would have just this term is equal to then 4 dy over dx minus this whole thing, minus this. All right, cool. Now I have all the dy over dx terms on one side. I can factor out dy over dx. So it's going to be, well, this left side doesn't change, equals, I factor out dy over dx. So that's, once I take it out of each of these terms, so I take it out, I'm left with just 4. Take it out of this whole term that's being multiplied together. Take it out of that, so I'm left with this. Cool. Then to get dy over dx by itself, I just have to divide both sides by that. So let's see, it's going to be, I'll put this in parentheses. This divided by that is equal to dy over dx. All right, I'm positive there's ways you can simplify this, but I don't think Delta Math asks us to do this. So let's just type this out. 1/2 x plus 3y to the negative 1/2 over 4 minus 3 over 2 x plus 3y to the negative 1/2. Did I type this out correctly? Don't want any mistakes. Good. Let's see. Sweet. Perfect. Excellent. All right. Hopefully this was helpful. I know these last couple are tedious, but it's important to go through each one of them. The first time it's going to take a long time. Second time it gets faster. You get faster and faster and faster at it. And eventually you stop making mistakes as well. So hopefully this was helpful. Let me know if you have any questions. All right.